So I've been wanting to learn more about Kubernetes recently, and this is because I've been working a lot more on working on securing things in Kubernetes, specifically EKS, which is AWS, AKS for Azure, and GKE for Google Cloud. And I've been really wanting to deepen my understanding of how Kubernetes works. And I've searched for various resources, certification resources, and training. And one of the best resources I found that was highly recommended was Kubernetes the Hard Way by Kelsey Hightower on GitHub. And I went to look at the project, and it looks like it's a really good way for me to learn Kubernetes the hard way. And in order for me to really understand the security components of Kubernetes, I think it would be important for me to go through this project to understand how Kubernetes works, all of the different components, and learn it the hard way. And then from there, I can start learning more about the security components of Kubernetes. So in this video, I'm going to be working on Kubernetes the hard way. I've never done this before, so everything here is just going to be me just doing stuff, trying to figure it out as I go, and learning more about the different components of Kubernetes. So with that said, let's just get right into the video. All right, let's get started. So here we are in the repository. It's Kelsey Hightower Kubernetes the hard way. And let's take a quick look at the README. So this tutorial walks you through setting up Kubernetes the hard way. This guide is not for people looking for a fully automated command to bring up a Kubernetes cluster. If that's you, then check out the Google Kubernetes engine or the Getting Started guides. Kubernetes the hard way is optimized for learning, which means taking the long route to ensure you understand each task required to bootstrap a Kubernetes cluster. So this is the main goal. I really want to understand, the internal components of Kubernetes, and so that's why we're going to be going through this hard process. So the result of this tutorial should not be viewed as production ready and may receive limited support from the community, but don't let that stop you from learning. Who's the target audience? So this target audience is someone planning to support a production Kubernetes cluster and wants to understand how everything fits together. I also think this is also good for anyone who is going to be securing a Kubernetes cluster and really wants to understand how everything fits together, which I fit that persona and, maybe other people out there. So these are the labs that we're going to be going through. These are the different, this is the cluster details. So this guides you through bootstrapping a highly available Kubernetes cluster. Say Kubernetes 10 times fast. With end-to-end encryption between components and RBAC authentication. And we have all of these. This tutorial assumes you have access to the Google Cloud Platform. While GCP is used for basic infrastructure requirements, the lesson learned in this tutorial can be applied to other platforms. I'm going to be going through this using GCP. I actually don't have a personal GCP account. I have a personal AWS and Azure account, and that's not to say I've not used GCP before. I've used some of the accounts I have access to from work for some testing purposes, but I don't have a personal account. So actually, I've been waiting for this to get a personal account so I can do it in one breath. So we're going to be doing that process in this video and getting started with everything. And these are the different steps we're going to be taking in order to deploy our Kubernetes cluster. So let's just go ahead and get started. So let's start with the prerequisites. So this tutorial leverages the Google Cloud Platform to streamline provisioning of the Kubernetes instance required to bootstrap a Kubernetes cluster from the ground up. So let's sign up for that. Okay, Google Cloud, get started for free. Close that page. Here's CYBERWOX. Yeah, it's fine. And let's do a personal project. I accept and I accept. Oh, actually, I'm in the United States, not Tuvalu. United States. Full disclosure, guys, I didn't show the entire process of the account setup simply because I didn't want to expose too much personal information, but it's a fairly easy setup, so definitely go ahead and do that, and let's move on to the next step in the process. All right, up next, we have to install the Google Cloud SDK, so follow the Google Cloud SDK documentation to install and configure a gcloud command line utility. So let's go ahead and do that. I'm trying to find an installation for Mac. So gcloud is okay. And let's see. Documentation. Install. Yes. Learn more. Okay. All right. So Mac OS. So let's grab our terminal. Let's do Python V or Python 3V. I'm pretty sure I'm using Python 3. Yeah, of course. All right, so we have to download one of the following. So Mac OS, I have the M1. So I'm gonna go ahead and download this one. Shouldn't take too long. And then extract the archive to any location in your file system, preferably your home directory. So let's do that. So let's first of all move that file. So download and move it to our home directory right here. All right, we have it right there. So let's do tar xvzf, I think. That file, Google Cloud. That's a lot of files. I think that's it. All right, perfect. And then let's run this script. Google Cloud install sh. And let's run that. Sweet. Do you want to help improve? No. Do you want to continue? So let's see, to install or remove, to update. Modify profile to update your path and enable, yes, let's do yes. Enter a path to an RC file or leave blank to use this one. Yeah, this one is fine. All right, clear. Let's do click a project to use. The project one. Someone just gonna choose that one. All right. And what's next? Let's see. Next, set a default compute region. So let's do that. gcloud config set compute region. Let's use US East 1. Would you like to enable this? Let's take it for yes, do yes. All right, this might take a little bit of time, so let's see what happens. All right, so up next we have running commands in parallel with tmux, and I won't be using tmux, so let's go on to installing the client tools. All right, cool. So let's see, in this lab, you install the command line utilities required to complete this tutorial. So cfssl, cfssl JSON, and kubectl. All right, so install cfssl. The cfssl and cfssl JSON command line utilities will be used to provision a private key or public key infrastructure. Which one? A public key infrastructure and generate TLS certificates. So download and install CFSSL and CFSSL JSON. All right, let's go ahead and do that. I'm gonna cheat a little bit here and just copy past the. So let's do paste that. Run that. So that's downloading CFSSL. That was fast. And we'll download the CFSSL JSON. I'm going to be doing a little cheating, just like copy and pasting a lot of these commands, but we're going to be analyzing these commands just to make sure that we really know what's going on. So here we're going to add the executable bit to both CFSSL and CFSSL JSON so we can actually use them. So let's go ahead and do that. Enter. All right, cool. And then we're going to move these files to our local/bin directory. So let's go ahead and paste that. All right, I'm gonna alternate between copying and pasting and all of those other things. All right, so it looks like everything is good here. Let me go ahead and put in my password. All right, sweet. Let me see if it works. Is there any way we can check if it works? Let's see. Verification. Okay, so we can do CFSSL version. Perfect, we got that working. And then we can do CFSSL JSON and tag version. Does that work? Let's see, let's run that again. CFSSL JSON. Oh, okay. I missed a space in the middle of that. All right, perfect. So both are working. And next we're going to install kubectl. So kubectl is a command line utility that is used to interact with the Kubernetes API server. download and install kubectl from the official release binary. So let's go ahead and download kubectl. So paste that curl command, and we should have kubectl. All right, sweet. Then let's add the executable bit to kubectl. So +x and kubectl. All right, and then we're gonna move kubectl to our user/local/bin directory. So kubectl/user/local/bin. All right, perfect. So we have kubectl done. Let's see if we have it done. So let's do kubectl version client. All right, looks like it works. All right, that's what we should have gotten, if I'm not mistaken. Yes, that's what it is. Sweet. We've gone ahead and we have installed the client tools. Up next, we're going to provision compute resources. So it's getting more interesting now. So let me actually make this smaller. All right, cool. So Kubernetes requires a set of machines to host the Kubernetes control plane and the worker nodes where containers are ultimately run. In this lab, you will provision the compute resources required for running a secure and highly available Kubernetes cluster across a single compute zone. So here we have ensure a default compute zone and region have been set as described in the prerequisites lab, and we've already done that. All right, so networking. The Kubernetes networking model assumes a flat network in which containers and nodes can communicate with each other. In cases where this is not desired, network policies can limit how groups of containers are allowed to communicate with each other and external network endpoints. Setting up network policies is out of scope for this tutorial. All right, no problems. So next we're gonna provision a virtual private cloud network to host the Kubernetes cluster. So we're gonna create the hardware custom VPC network. So let's go ahead and do that. So I'm gonna try to type out these commands so that I can kind of just know them by heart, at least some of them. So Kubernetes, so gcloud compute network create Kubernetes, the hard way, and then subnet mode is going to be custom. And this might take a little bit of time, but let's read this while it provisions. A subnet must be provisioned with an IP address range large enough to assign a private IP address to each node of the Kubernetes cluster. So create a Kubernetes subnet in the Kubernetes hardware VPC network. All right, cool. So it looks like we already have this provisioned. So let's take a quick look at it. So created the network name, something more custom. All right, cool. Let's go ahead and create the subnet. So let's do that. So it's going to be gcloud compute networks subnets create. So Kubernetes and network Kubernetes, the hard way, and then the range, it's going to be a 10.240.0.0/24. So we have gcloud compute networks subnets create Kubernetes, and then the network, in this network Kubernetes the hardware which we just created, and this CIDR range. So this range can host up to 254 compute instances. Nice. And this might take a little bit of time because we're provisioning resources, but that was pretty fast. So we have the subnetwork created. Its name is Kubernetes, and it's in region 1, and it has this range, and it's IPv4 only. Sweet. Then we're going to go ahead and create firewall rules that only allow internal communication across all protocols. So once again, I'm going to type all of this out. gcloud compute firewall rules, and we're going to create Kubernetes. I wish this is where I could just tap this. Yep, it's yelling at me for tabbing. So create Kubernetes the hard way, and then allow external. So I'm assuming this is a set of firewall rules that are going to be called Kubernetes the hard way, allow external. Just like you can have like, I think like security groups in like AWS. So allow, so it's the tag. So allow, so we're allowing TCP port 22, which is a SSH. And then we're also allowing TCP port 6443. And then we're also going to allow ICMP. Then what else? Network, the Kubernetes the hard way subnet we just created. So Kubernetes the hard way, and then source ranges. So this is going to be from source ranges. This is going to be from 0.0.0.0/0. So it's from any IP address that ever exists. So let's look at this once again. Gcloud compute firewall rules, and then create Kubernetes the hard way, allow external. This is the name of the firewall rules, and we're going to allow TCP port 22. I think I missed something. So I was supposed to allow TCP, UDP, and ICMP. Okay, so I think you first start by allowing the protocols, or have I already done that? Yes, I am one step ahead. So let's go ahead and clear this out. So I was way too ahead of myself there. So it's just supposed to be, this is the first one. All right, so we're supposed to allow internal first. So Gcloud compute firewall, Kubernetes hardware allow internal. All right, that's the first one. And then allow TCP. Okay, we're gonna allow TCP protocols, UDP protocols, and then ICMP protocols. And then the network is gonna be Kubernetes the hard way. And then the source ranges is going to be from specific IP address ranges, which are private IP address ranges. So I think the internal communication is going to be for only things that are in our Kubernetes cluster or clusters. So these are specific IP address ranges I think we might be provisioning later on. So 24 and then 100. Oh, sorry, 10. 24, comma 10.200.0.0/16. Okay, so those are pretty decently sized networks. So let's check that one more time. So Kubernetes the hard way, allow internal, allow TCP, UDP, ICMP. The network is going to be Kubernetes the hard way, 10.240.0.0/24 and 10.200.0.0/16. So those are, okay, what did we miss? So those are the internal. So let's fix that. So 10 dot. Okay, we didn't specify source ranges. See, this is what happens when you decide not to copy and paste. But it's for the greater good. It's for the greater good. And all of these mistakes help you understand better because now you remember something that you missed. So sweet. So let's go ahead to create that firewall rule for internal communication. Perfect. So we have the inbound access for these different protocols. Next, we're going to do for external. So pretty much the same thing, but this time we're going to define Kubernetes the hard way, allow external instead of internal. And let's change that to external. And we're going to allow TCP port 22, which is for SSH, which makes sense because we're going to be doing stuff with SSH. And then TCP port 6443. That's an interesting one that I haven't seen before. And then also ICMP, then network Kubernetes the hard way, and then source is going to be 0.0.0.0/0, which is any IP address. So that means this is going to be available to anyone. So 0.0.0/0. Sweet. So it's creating a firewall. And here it says an external load balancer will be used to expose the Kubernetes API servers to remote clients. All right, cool. So let's confirm that. So we have, this is the name of the firewall, and then this is the network it is on, the previous subnet we created, and this is ingress. And this is priority 1000 and TCP port 22. TCP port 6443, and ICMP. Okay, looks like we did everything right. Perfect. So next we're going to list the firewall rules in the Kubernetes hardware hosting network. So let's go ahead and do that. So gcloud, compute, firewall, rules, list, and we're gonna filter by network is Kubernetes. How do you spell Kubernetes? Kubernetes the hard way. All right, perfect. So we have that result. So it shows the two firewall rules we just created for external and for internal. Sweet. Next, allocate a static IP address that will be attached to the external load balancer front end, the Kubernetes API service. So I'm going to copy this because I don't want to make mistakes with some specific things. So copy and paste. So what this is essentially doing is, so gcloud compute addresses creates Kubernetes the hard way region. So it's going to use this variable, which is basically just it's entering a command for getting the value of our default compute region. So let's run that. All right, so we have that public address created, and let's verify the static IP address was created. So let's type that command out. So gcloud compute addresses list, and then filter is going to be name equals open colon Kubernetes the hard way, close that, and enter. All right, sweet. So that's our public IP address, and we're all set with that. All right, so next we're gonna provision the compute instances. So the compute instances in this lab will be provisioned using the Ubuntu Server 20.04, which has good support for the container runtime. Each compute instance will be provisioned with a fixed private IP address to simplify the Kubernetes bootstrapping process. So create 3 compute instances which will host the Kubernetes control plane. So I'm not gonna type this out. I'm just gonna copy and paste this, but this is basically a for loop. So for each instance and for each number in 0, 1, 2, do this, and then each of these variables is going to be inputted into the command. So it's going to create a compute instance controller 1, controller 0, controller 1, and controller 2 with a disk size of 200 gigabytes. Can IP forward with this Ubuntu image. This is the machine type. It's going to be in this private network. So for each of the instances is going to be 240.0.1, 0, the 1.1, the 1.2, I believe, and then the scopes are going to be all of these, and then it's going to be in the subnet we created, and then going to have these tags, and then done. So it's going to do this for 3 instances, 0, 1, and 2. So let's go ahead and copy and paste that. Click enter. This might take a little bit of time. So let's see. What do we have here? Too many options. Enter list. Please enter your. Okay. So, Asia. Oh, that's interesting. It's asking me that. For the following instances, choose a zone. Okay. Huh. Let's do list. Okay. US. Okay. Yeah, I thought I already said a default zone, but let's do a US East 1B. Since there's just that. Okay. We'll do US East 1B. So that's gonna be 80. US East 1B is 80. All right. Let's do 80 again. And then for the last time, 80. All right, cool. So it looks like we've done that for our 3 instances. The users will be charged for public IPs, blah, blah, blah. All right, looks like everything is set. Okay, so each worker instance requires a pod subnet allocation from the Kubernetes cluster CIDR range. The pod subnet allocation will be used to configure container networking in a later exercise. Okay, so the pod CIDR instance metadata will be used to expose pod subnet allocations to compute instances at runtime. And Kubernetes cluster CIDR range is defined by the controllers manager cluster side flag, and in this tutorial, the cluster side range will be set to that IP address, which supports 250 subnets. So create 3 compute instances which will host the Kubernetes worker node. So the first 3 compute instances were for the control plane, which is for the controllers, and then these 3 instances are going to be for the worker node. So we're going to go ahead and copy that. It's pretty much the same thing, but just different name with a worker in them. So let's copy and paste that. And let's just do 80 again. I believe that's what we had the other time. Actually, let me list some short of this. And yes, it was 80. So 80, first one, and 80 for the second one, 80 for the third one. All right, sweet, perfect. And then verification, G-Cloud compute instances list. All right, so let's confirm that we have everything set. So G-Cloud compute instances list, and then filter by this tag. So that's probably why we created those tags in the first place. So tags is Kubernetes the hard way. And let's do that. Oops. Unrecognized. Compute filter. Oh, I missed something here. So filter equals tags, not dash tags. All right, perfect. So everything has been created. So we have controller 1, controller 2, controller 0, worker 0, worker 1, worker 2, and they have the internal IPs and their external IPs, each provisioned according to the number of your controllers. So .10, .11, .12, .20, .21, .22, and then their public IP addresses. Awesome. So let's go ahead and configure SSH access. So SSH will be used to configure the controller and worker instances. When connected to the compute instance for the first time, SSH keys will be generated for you and stored in the project or instance metadata as described in the connecting to instances documentation. Test SSH access to the controller 0 compute instances. So let's go ahead and try that. So G-Cloud compute SSH controller 0. All right, enter passphrase. Since this is a test environment, I don't want to be typing multiple passphrases. I'm just gonna keep enter without any passphrase. But of course, in production environment, if you want to have a passphrase at the least. But just for ease of access, I'm just gonna make it without any passphrase. All right, so if this is your first time connecting to a compute instance, SSH keys will be generated for you. Enter a passphrase. We already went past that. At this point, the generated SSH keys will be uploaded and stored in your project. Awesome. So that is fine. And after the SSH keys have been updated, you'll be logged into controller 0. All right, so we are actually in controller 0, right? Sweet. All right, and that's awesome. So we're actually in controller 0 right now. Of course we are, because we SSH into it. Then what do we have next? So type exit at the command prompt to exit the controller 0 compute instance. So let's go ahead and do exit. All right, we're back to reality. All right, so that was it. So we just basically provisioned our compute resources. Next, we're going to provision a certificate authority and generate TLS certificates. So in this lab, you will provision a PKI infrastructure, which is a public key infrastructure, using Cloudflare's PKI toolkit, CFSSL, then use it to bootstrap a certificate authority and generate TLS certificates for the following components: the etcd, kube API server, kube controller manager, kube scheduler, kubelet, and kube proxy. So certificate authority, in this section, you will provision a certificate authority that can be used to generate additional TLS certificates. Generate the configuration file, certificate, and private key. So before we just copy and paste, I'm just going to take a look at this. Let's see. Sign in, expiry, 8760, blah, blah, usage, sign in key, encipherment, server authentication, and client authentication. Another file is going to be created. So it's going to be RSA and then names and then this command. All right, let's go ahead and run this. This is going to basically generate the CA configuration file, the certificate, and the private key. So let's go ahead and do that. Enter. All right, sweet, perfect. We have that. And let's do an ls, and we should see that. All right, so we have it right here, ca config. Actually, yeah, so we have it ca key the pem and ca the pem. Next, we have the client and server certificate. So what we just did is the certificate authority, and now we're going to do the client and server certificate. And in this section, you will generate client and server certificates for each Kubernetes component and a client certificate for the Kubernetes admin user. The admin client certificate is going to be generated. So it's going to be generate the admin client certificate and private key. All right, let's go ahead and let's take a look at that. Certificate name is admin key. The algorithm is RSA, and the names, all of this, and then, all right, cool. Let's go ahead and generate those certificates. Let's just copy and paste that, and let's do an ls, and we should be able to see those files over there. All right, next we're gonna create the kubelet client certificate. So Kubernetes uses a special purpose authorization mode called node authorizer that specifically authorizes API requests made by kubelets. In order, so what's a kubelet actually? See, let's take a quick look at what a kubelet is. Let's see, F kubelet. All right, so a kubelet is an agent that runs on each node in a cluster. It makes sure that containers are running in a pod. A kubelet takes a set of pod specs that are provided through various mechanisms and ensures that containers described in those pod specs are running healthy. The kubelet doesn't manage containers which were not created by Kubernetes. So it's basically an agent, right? Cool. So the Kubernetes uses a special purpose authorization mode called authorizer that specially authorizes API requests made by kubelets. In order to be authorized by the node authorizer, kubelets must use a credential that identifies them as being in the system nodes group with the username of system node and then the node name. In this section, you will create a certificate for each Kubernetes worker node that meets the node authorizer requirements. So we're going to go ahead and generate a certificate and private key for each Kubernetes worker node. And let's see what we have here. So for each instance, worker 0, worker 1, and worker 2. So we're going to go ahead and do this. So for each of these instances, we're going to create the instance name, csr.json file, and then in that file, we're going to have this, and then create this environmental variable, I believe, or not, and then this. Don't fully understand what is going on in this part, but let's go ahead and do what we have there. So it's doing it for each of the instances. So worker 0, worker 1, worker 2, and looks like we've created a certificate and private key for each of the worker nodes. So let's do an ls, and we should see each of those files. So worker 0, worker 1, worker 2 have their files. Next, we have to generate client certificate and private keys for the kube controller manager. So same thing here. So it's gonna create a file, a JSON file for the kube controller manager, same RSA algorithm, and run these commands. So let's go ahead and do that. Once again, I'm gonna copy and paste this, and warning. Looks like it was created, but we do have a warning. But that looks fine. So let's do a ls again, and we should see the kube controller manager key, and we have that here. And we have that here. Perfect. Next, we're going to generate a kube proxy client certificate and private key. Same thing here. Create this JSON file, and it's gonna have this information, same RSA, blah blah blah. So let's go ahead and copy that and paste it. And we have that all set, and we're doing ls. We should see kube proxy, CSR, and kube proxy. So we're pretty much just creating, as the name implies, if I'm not wrong. Yeah, we're just creating certificate authorities and generating TLS certificates, which is fine. All right, cool. So what did we just do? What did I miss? Oh, yeah. So I just created the kube proxy client certificates. Okay, perfect. Next we're gonna do the ones for the scheduler. So let's go ahead and copy and paste it. Same thing here. All right, and if we're doing ls, we should see same thing for kube scheduler. Awesome. Next, we're gonna do the same thing for the Kubernetes API server certificate. So the Kubernetes the hardware static IP address will be included in the list of subject alternative names for a Kubernetes API server certificate. This will ensure that the certificates can be validated by remote clients. So generate the Kubernetes API certificates and private key. So let's go ahead and do that. First of all, take a look at what the command is doing. So it's first of all creating a variable for the public IP address, which can be found with this command. Region can be found with this command, and then define a format, and then host names defined here, and same RSA and the same commands using CFSSL. So let's go ahead and copy that. Still don't fully understand what everything's going on, but I conceptually understand it. The thing with Kubernetes is like there's so much abstraction, there's so many things, there's so many components, and it takes some time to just kind of wrap your hand around everything that's going on. But I do understand what is going on to an extent. So let's continue. The Kubernetes API server is automatically assigned the Kubernetes internal DNS name, which will be linked to the first IP address from the address range this and reserved for internal clusters services during the control plane bootstrapping process. All right, so let's do ls, and we should have that Kubernetes key. If I'm not mistaken, Kubernetes key. All right, there we have it. Kubernetes.pem and Kubernetes key.pem. All right, the Kubernetes controller manager leverages a key pair to generate and sign service account tokens as described in the managing service account documentation. So we're going to go ahead and generate the service account certificate and private key. Let's look at this documentation real quick. So this is a cluster administrator guide to service accounts. You should be familiar with configuring service accounts. So just general information about service accounts and how they work and what they're used for in Kubernetes. That's more studying for me to do, but let's go ahead and copy that and paste. So this is really the hard way because we're doing literally every single thing, like no sort of like automation script. So it really is the hard way. So next, copy the appropriate certificates and private keys to each worker instance. For instance, in worker 0, worker 1, do this. So copy those keys, and then also do the same thing to copy the appropriate certificates and private keys to each controller instance. So let's go ahead and copy those commands. So it's gonna run that loop for each of the worker nodes, and when this is done, it's gonna do the same thing for each of the controller nodes, each of the controllers. Make sure I'm using the right nomenclature there. All right, so let's go ahead and paste that for the controller node for the controllers, and it's gonna do the same thing. And it says here the kube proxy, kube controller manager, kube scheduler, and kubelet client certificates will be used to generate client authentication configuration files in the next lab. Sweet. Let's go ahead and continue. So we're going to go ahead and generate Kubernetes configuration files for authentication. Let's see how far are we. We're in 5. How much more do we have left? Because of the wait. Okay, yeah. So we're just kind of like, we're not even halfway yet. Let's continue. So generating Kubernetes configuration files for authentication. In this lab, you will generate Kubernetes configuration files, also known as kubeconfigs, which enable Kubernetes clients to locate and authenticate to the Kubernetes API server. So locate and authenticate to the API server, okay? Client authentication configs. In this section, you will generate kubeconfig files for the controller manager, kubelet, kubeproxy, and scheduler clients, and the admin user. Kubernetes public API address. Each kubeconfig requires a Kubernetes API server to connect to. To support high availability and IP address assigned, the IP address assigned to the external load balancer fronted to Kubernetes API server will be used. So let's go ahead and retrieve the Kubernetes, the hardware static IP address. So we're gonna store that in a environmental variable. So we do echo Kubernetes public IP address. All right, there it is. Next, the kubelet Kubernetes configuration file. When generating kubeconfig files for kubelet, the client certificates matching the kubelet's node the Kubernetes node name must be used. This will ensure kubelets are properly authorized by Kubernetes node authorizer. The following commands must be run in the same directory used to generate the SSL certificates during the generated TLS certificates lab. So we're still in the same directory, so that shouldn't be an issue. So for each of these instances, do this. It's gonna run this for loop for each of the instances. So set cluster, and then also relate those to like the certificate files we have in this directory and then for each of the workers. So let's go ahead and do that. All right, and then let's do an ls, and we should have those files. So worker one, the kubeconfig. All right, we have all of them. Next, generate a kubeconfig file for the kube proxy service. Kind of like the same thing. So let's go ahead and paste that. All right. And generate a kubeconfig file for the controller manager service. Once again, copy pasta. And then generate a kubeconfig file for the kubescheduler service. Same thing. Those files are already present in this directory, so you're just using those files for each of the workers or controllers. And also do the same thing for the admin user. So copy pasta one more time. And then finally, we're going to distribute the Kubernetes configuration file. So copy the appropriate kubelet and kube proxy kube config files to each worker instance. So for each instance, so it's going to compute SCP, the instance.compute file, and then kubeproxy.conf. So this script is going to essentially do that for us for the kubelet and the kube proxy. All right, let's go ahead and copy that. So it's going to run through worker 0, worker 1, and worker 2. There we go. All right, awesome. And same thing for the kube controller and kube scheduler. It's going to run through all three. So worker controller 0, controller 1, and controller 2. Oh, okay, we have an error there. Oh, let's see. What is the error? Why are we getting an error? No zone specified using US East 1B for instance. Error exited with return code 1. No zone specified. No such. Okay, so might have missed something. So let's go ahead and add that. Okay, hopefully that works. Go back here and run this command. Hopefully we don't get any. Ooh, okay. We got more errors. Again. Kube scheduler. Oh, it's kind of interesting. I don't know how I missed those, but let's run that. And then let's run it again. So let's go ahead and paste that. And hopefully it works this time without any errors. Okay, sweet. Please no errors. There we go. So it runs without any errors. So it's really nice how they have like very clear error so like you know what you're missing. So no such file directory. So this kind of made me know that I was missing something. Sweet, that's perfect. So next we're gonna generate the data encryption config and key. So Kubernetes stores a variety of data, including cluster state, application configurations, and secrets. Kubernetes supports the ability to encrypt cluster data at rest. In this lab, you will generate an encryption key and an encryption config suitable for encrypting Kubernetes secrets. So let's first of all generate an encryption key. So I'm going to paste that. And that's stored in the environmental variable. Next, we're going to create the encryption config YAML file. So let's go ahead and copy that. And it's just going to refer back to that environmental variable we just created in the last command. So copy the encryption config.yaml file to each controller instance. Once again, another script to run that across all three controller instances. All right, so we've basically generated the data, encryption config, and key. And that is for number 6. All right, so we're moving through it. So next we're going to do bootstrapping at CD. let's go ahead and do bootstrapping the etcd cluster. So etcd, I think etcd is basically like a key value store. So Kubernetes components are stateless and store cluster state in each etcd. So yeah, so I think the cluster state is usually stored in etcd using I believe a key value method. Yeah, so it's a distributed, reliable key value store for most critical data of distributed systems, and in this case, Kubernetes. So, all right, so prerequisites. First of all, let's look at this. In this lab, you will bootstrap a 3-node etcd cluster and configure it for high availability and secure remote access. So we're gonna configure a cluster for 3 nodes for etcd. That's going to be for high availability and secure remote access. So the commands in this lab must be run on each controller instance. So we're going to log into each controller instance using the gcloud command. All right, so this is probably where tmux would have been super beneficial. But what I'm going to do is I'm just going to make new ones and just make that 3. And if we're doing Kubernetes the hard way, might as well do it the hard way, right? And let's grab that 3rd one. Awesome. Awesome. All right, sweet. So gcloud compute SSH. So we're going to SSH into all 3 instances. So it's going to be controller 1 and SSH to controller 2. And this is going to be SSH into controller 3. All right, perfect. What am I missing here? Oh, this is going to be 80. That should already be set. Controller 3. List. $80 was not found. Oh, wow. Okay, this is interesting. Oh, okay, that was my fault. Okay. Yeah, I was typing in the wrong command. So this should be controller. So I have controller 1 here, controller 2, and it's supposed to be controller 0. Yeah, I was like, what am I doing wrong here? I was counting the wrong way. So controller 0, controller 1, controller 2. Just make this smaller for the cell so I can just have enough space for all 3 to just sit there and have a nice screen to stare at for each of the controllers. Let's grab the 3rd one and put it right under there. Awesome. Let's just make these stretch out a little bit. All right, perfect. Don't we love that look? So let's clear. Close that out. All right, and then let's clear this one as well. Sorry, no. And then clear here as well. All right, it's gonna be fun. So let's get back to where we were before. What are we doing? All right, so we're going to, okay, we're not using tmux, which is fine. So download and install the etcd binaries. So we're gonna do all of these things on all 3 controllers. So download the official etcd binary release. So let's run this on controller 0, same thing on controller 1, and same thing for controller 2. So we have that. Extract and install the etcd server and the etcd command line utility. So let's go ahead and copy that. So we're gonna install, and then do the same thing here, same thing here. Perfect. Configure the etcd server. So let's go ahead and do that. So make a directory for this and modify the permissions, and then copy that file into this file. All right, perfect. Let's do that. And let's do that here. And then let's do that here as well. Awesome. The instance internal, oh, actually, am I missing something? I did this, I did that. And did I do that? Let's see. What commands have I run? Okay, I've done them. All right, so next, configure the etcd server. Have I done that? So then make directory. Yes, I have done that. All right. The instance internal IP address will be used to serve client requests and communicate with the etcd cluster peers. Retrieve the internal IP address for the current compute instance. So we're gonna use like the metadata service to store the IP address in a variable, in a environmental variable for each three. So let's run that as well here, and then controller 2. So create the etcd service system unit file. So it's gonna create the etcd service file with all of those keys that we had, and then all of that. So let's do that for all three. And for 0, for 1, and for 2. All right, so we're gonna go ahead and start the etcd server, reload, and then enable so it can start on start. So the server can start on start. All right, so let's go ahead and paste that. And awesome. So this is the verification. List the etcd cluster members, and let's go ahead and do that for this one first. See what it gives us. Let's see, is that what we should be getting? Has a warn. West connection error. Let's see if it works with this one and this one. Might have missed something along the way. Connection refused, connection refused. All right, so we probably are missing something here. Remember to run on each controller, verification. Let's see, let's run that command again. Maybe just took some time. CD Cado API members list. Deadline exceeded. Huh. Interesting. What are we missing here? We did this, we did that. Oh. Yeah, I missed this. Definitely missed this. Okay, let's do this again. And then here. So each etcd must have a unique name within an etcd cluster. Yeah, I definitely missed that. And we have that file. So let's run that command again. Hopefully it works this time. Might have to restart, but let's see if it works. Let's run it here too. Okay, I'm gonna go ahead and I already have this file. Let me ls. I have that etcd service file. Etcd. I think it was moved eventually. Was it moved? Sudo t. I'm gonna go ahead and restart the. Let's do this again. Okay, let's try restart. So let's try sudo system call restart etcd. Let's see, sudo system gonna restart. Goes to control accept the error code. System call status etcd service. Oh, non-operation. Oh, okay. Oh, status. I meant to type status. Failed to start etcd. Yeah, that definitely makes sense. Let's see. Probably missing something. Okay. Okay. Let's clear this out. So we already have this. We have etcd and extract. I'm gonna go ahead and run this one more time. Try to make sure I don't miss anything this time. So extract. All right. Control C. Extract again, and then do this again. All right, and then configure the etcd server. Let's do that. We have this here, and this here, and then get the internal IP address for all three stored in that environmental variable. get that, and that, and then the host name. So grab that, and grab that. Same thing for the etcd.service file, and then enter that. Oh, I might have done that. That's probably what I'm missing. Let's go ahead and do the start. Go ahead and start here, and start here. Okay, hopefully it works this time. Okay, all right, and then let's do the verification, and oh yes sir, there we go. Everything works now. Yeah, I definitely missed something the first time I went around it. So started controller 2, so we can see all of our controllers. Perfect. Next thing we're going to do is bootstrap the Kubernetes control plane. So in this lab, you will bootstrap the Kubernetes control plane across 3 compute instances and configure it for high availability. You will also create an external load balancer that exposes the Kubernetes API server to remote clients. The following Kubernetes will be installed on each node: Kubernetes API server, scheduler, and controller manager. The commands in this lab must be run on each controller instance. So controller 0, 1, and 2. And then we already logged into them. So first we're gonna provision the Kubernetes control plane, and the first step in that is to create the Kubernetes configuration directory. So let's make that directory an L3. So make directory Kubernetes config, make directory Kubernetes config, make directory etc/Kubernetes config, and then next step is to download and install the Kubernetes controller binaries. So we're gonna download the official Kubernetes release binaries. So let's do that here, and do that here, do that here. And then next we're gonna configure, we're gonna install the binaries. So first of all, add the executable bits and then move those files into our local/bin directory. Let's do that here, and do that here. Then we're gonna configure the Kubernetes API server. So we're gonna make a directory for, we're gonna make this directory, and then we're gonna move these files into, okay, so those certificate files that we created and the encryption file that we created, we're going to move them into these files. So let's go ahead and do that for each controller. All right. And then the instance internal IP address will be used to advertise the API server to members of the cluster. Retrieve the internal IP for the current compute instance. I think we already did that, but let's go ahead and do it again. We did that in the last step, but we're going to go ahead and do it again. So basically just curling the metadata service and storing that information in the environmental variables. That's going to be the internal IP. Then we're also going to do the same thing for region. So we're going to store that in another environmental variable. So paste that. All right. And then create the kube.api server, the service system unit file. And this file contains relations to all of those like key files we created in like when we created those TLS certificates and certificate authorities. So let's go ahead and do that for all 3. And then next we're going to configure the Kubernetes controller manager. So first step is going to be to move the kube controller manager kubeconfig into place. So move that file into that Kubernetes file in our varlib directory. So same thing here, and same thing here. Then we're going to create a kube controller manager, the service system unit file, once again relating all of this information to all of those certificate files that we created earlier on. So let's do that. Let's do that here, and we're going to do that here again. Configure the Kubernetes scheduler, move the kube scheduler kubeconfig into place. So we're going to move that file into that into our varlib Kubernetes directory. Oops. Wrong command. Let's copy this and copy this and copy this. All right. Then we're going to create the kube scheduler, the YAML configuration file, and it's going to be in our Kubernetes config directory. Let's go ahead and do that. So controller 1, that for controller 2, that for controller 3. And then next we're going to create the kube scheduler, the service system unit file. So many files. This is really Kubernetes the hard way. So many things going into Kubernetes, which is why it's, that complicated. So next we're gonna start the controller services. So we're gonna start Kube API server, Kube controller manager, and Kube scheduler. So let's go ahead and do that. This and then for this. Sweet. Next, we're gonna enable. Okay, so we're gonna wait for 10 seconds for the Kubernetes API server to fully initialize. But while we wait for that, we're gonna read this. So enable HTTP health checks. A Google Network load balancer will be used to distribute traffic across the 3 API servers and allow each API server to terminate TLS connections and validate client certificates. The network load balancer only supports HTTP health checks, which means the HTTPS endpoint exposed by the API server cannot be used. As a workaround, the Nginx web server can be used to proxy HTTP health checks. In this section, Nginx will be installed and configured to accept HTTP health checks on port 80 and proxy the connections to the API server on this 127.01 and port 6443. Oh, that's probably why we use port 6443 in the firewalls /health. That makes sense because we made a firewall rule that had port 6443 earlier on. So let's go ahead and install a basic web server to handle HTTP health checks. So first of all, do an update, and then we're gonna install Nginx with all ESs using that tagline. All right, looks like this is almost ready. And then next we're gonna create a file. It's just basically gonna say listen to port 80 and this, and then the proxy pass, and then define the trusted certificate. Okay, let's go ahead and do this command. So it's gonna install Nginx. It's first of all did the apt-get update. So let's install Nginx. And while we wait for that, we're gonna copy this command. All right, it looks like it's installed for controller 2. So let's go ahead and make that file for controller 2. It's like controller 1 and 0 are taking their precious time. Just gonna be patient with them. Just patient with them. All right, looks like they're both ready for this file and this file. All right, and then next, I'm gonna do this file as well. I'm just gonna move this into this, and then go ahead and do this. All right, let's go ahead and do that. And then this. All right, and then we're gonna restart the Nginx service and then enable the Nginx service. So restart, restart, and restart. And then we're gonna go ahead and enable the Nginx service. Enable, enable, and enable. All right, verification. Let's go ahead and run that verification. So it's running on this. This is what we want to see. Perfect. So everything's working fine for controller 0. It's running on this. Everything's also working fine for controller 1. And this, everything is also working fine for controller 2. Perfect. Then we're going to go ahead and test the Nginx HTTP health check proxy. So let's run this command. So just curly host this, and then instance that IP address /health. All right, everything's looking good. We have a really nice header here showing us everything's working fine, and we got that okay. Same thing here, we got that okay. Nice header. Got the date, shows us it's running Ubuntu. Same thing for controller. Oops. Let's copy it again. For controller 2. Whoa, what's going on? Come on. Copy this. And let's paste. What do I miss? Oh, wrong command. Wrong command. Okay. Wrong command. Let's paste that. There we go. So we got that okay. Got 200 okay. Means everything is working. Awesome. All right, next we're going to do role-based access control for kubelet authorization. In this section, you will configure role-based access control, also known as RBAC, permissions to allow the Kubernetes API server to access the kubelet API on each worker node. Access to the kubelet API is required for retrieving metrics, logs, and executing commands in pods. This tutorial sets the kubelet authorization mode flag to webhook, and webhook mode uses the subject access review API to determine authorization. It's very interesting. I worked on a detection on this recently. All right, next, the commands in this section will affect the entire cluster and only need to be run once from one of the controller nodes. So we're gonna do it from controller 0. So let's create the system API server to kubelet cluster role with permissions to access the kubelet API and perform most common tasks associated with managing pods. So this file, I believe, basically defines permissions to access the kubelet API and perform most common tasks associated with managing pods. All right, that was a mouthful. And I've been talking for like over an hour now. So we've created that file. Next, the Kubernetes API server authenticates to kubelet as the Kubernetes user using the client certificate as defined by the kubelet client certificate flag. Bind this cluster role to Kubernetes user. So we're going to bind this system role to the Kubernetes user. Oh, now that makes sense. So cluster role bindings. Oh, that makes sense. See, some of these things are just making sense because I've done some work on like Kubernetes detections, and I'm now understanding some of the purposes of what I was doing, especially like detections for like role bindings and stuff like that. So it's pretty interesting to actually get to do these hands-on. All right, so the Kubernetes front-end load balancer. In this section, you will provision an external load balancer to front the Kubernetes API servers. The hardware static IP address will be attached to the resulting load balancer. The computer instances created in this tutorial will not have permission to complete this section. Run the following commands from the same machine used to create the compute instances. Okay, so we're gonna need another terminal for that. All right, I hope I'm doing this right. Let's do command N. It's a new terminal. So create the external load balancer network resources. So basically, we get the IP address, and then HTTP health checks, and then gcloud compute, firewall. Okay, it's going to create another firewall for the health check. And then a target pool, going to add instances, and then forwarded rules. All right, let's go ahead and do that. So this is a bunch of resources. This might take a little bit of time. Okay, so we created the first resource, and then it's going to go ahead and create a firewall, which has been created. And then target pool, 80. All right. So verification, we're going to run this command when it's ready. So let me just copy it down so that once it's done, I can just paste it there, and there it is, it's done. So everything has been created. So let's go ahead and paste that command to determine if everything works fine. Okay, so we can actually, so we already have the IP address, and then make an HTTP request for the Kubernetes version info. So let's curl. Ooh, could not resolve host. Oof. Okay, what are we missing? Okay, maybe we just need to wait a little bit of time. We already made this file. And we already did this. So curl. Oof, could not resolve host. Okay, let's see what we're missing. Static IP address. Probably have some of these resources still provisioning. So maybe just wait a little bit. I just want to make sure I did everything. All right, so let's go ahead and try it again. I've waited a little bit of time. Once again, we'll confirm that all of the network load balancer resources are present. It already exists, so that is working fine. And this already exists, I'm sure. All right, so that's fine. And let's go ahead and curl that again. All right, so I'm gonna just go ahead and do this. I'm going to grab this command right here. Actually, I'm just go ahead and type it out. Gcloud compute addresses describe Kubernetes the hard way so I can get that public IP address. All right, 34.139.45.198. And then what I'm going to do is going to concatenate that into that curl command instead of that. Uh, instead of that, so I'm just gonna do this instead. So clear that out. And then I'm going to type in that IP address directly. So 34.139.45.198. All right, perfect. Looks like it works. There we go. I don't know why it's not working with the environmental variable. For some reason, yeah, it's kind of weird. It's not working with the environmental variable. But at least we got the results, and it looks like everything is working fine. So that's it for what step did we just complete? That's that for bootstrapping the Kubernetes control plane. So we're gonna go up to step 9, which is bootstrapping the Kubernetes worker nodes. So in this lab, you will bootstrap 3 Kubernetes worker nodes. The following components will be installed on each node: runc, container networking plugins, containerd, kubelet, and kubeproxy. So we're going to SSH into the worker nodes. So let's go ahead and do that. I'm going to move these controller nodes that I'm SSHed into to another part of my screen and do the same for the worker nodes. So I'm going to go ahead and do that. So compute SSH worker 0. All right, perfect. So let me make this smaller, and then, all right, I have this, and then I'm just gonna make a new tab and just open it up here, try that out here, and then run this command. But this is gonna be worker 1, and then I'm gonna make a new tab or a new terminal. Make this smaller so that I have more space. All right, and move this up and pull this down, then bring this here, and just really want to make sure the screen is nice and clear and easily accessible. And then we're going to connect to worker 2, which is the third one. Worker 2. All right, perfect. So what are we going to do in this stage? So we are not using tmux. So we're going to go ahead and provision Kubernetes worker node. So install the OS dependencies. So first of all, update, and then install the dependencies. So that here, do that here, and do that here. So the SOCAP binary enables support for kubectl port forward command. Okay, that's good to know. I think that it's just okay. So it's done the update and then it's installed the SOCAP binary. So we're gonna disable swap. So by default, the kubelet will fail to start if swap is enabled. If it is recommended that swap be disabled to ensure Kubernetes can provide proper resource allocation and quality of service. So let's verify first if swap is enabled. So okay, so we don't get any response here. If output is empty, then swap is not enabled. I might make a pull request to fix this. So if output is empty, then swap is not enabled. If swap is enabled, run the following command to disable swap immediately. So it looks like it's not enabled. So next stage is download and install worker binaries. So let's go ahead and do that. So copy, paste that for controller 0. These are all from GitHub. All right. Perfect. So we have that installed for worker 0, worker 1. Then create installation directory. So we're going to create multiple directories here in our etc folder, and then our opt folder, and our var lib folder. Let's go ahead and do that. Perfect. Then next we're going to install the worker binary. So make a directory and then untar these files and then move these files, add executable bits. Sweet. Let's go ahead and do that. So worker 0, worker 1, and worker 2. Next, we're going to configure CNI networking. So retrieve the pod CIDR range for the current compute instance. So we're going to store that in an environmental variable. And then create the bridge network configuration file. So this is going to be the bridge network configuration file, bridge.conf. All right, let's go ahead and do that. Go ahead and do that. It looks like it is. So destination, any IP address, and then we're going to create a loopback network configuration file. Let's go ahead and do that. All right, then configure container D. So make a directory for container D in our etc directory. Let's do that here, here, and here. Then make this file, this toml file with the plugins for container D, and then create the container D service system unit file, system D unit file. Go ahead and do that. Go ahead and do that here as well. All right. Then configure the kubelet. So move the hostname kubectl file here, move this here, move this here. All right, let's go ahead and do that. So the certificate files and kubeconfig files, and then create the kubelet config.yaml configuration file. All right, let's go ahead and do that. It's like a lot of things in Kubernetes use YAML. I think YAML is also like used for like the manifest file. Still have a lot to learn about Kubernetes. All right, so the resolve configuration is used to avoid loops when using core DNS for service discovery and systems running systemd resolved. All right, next we're going to create a kubelet service systemd unit file. Let's go ahead and do that for here, here, and here. A lot of copy and pasting because these files are they have like their purposes, and I feel like until you really understand like the different components of how Kubernetes works in depth beyond this, it's kind of hard to decipher what they're doing. But at a high level, I can understand what each of these files is doing just by looking at what the file is saying. So next, configure the Kubernetes proxy. So let's move this file into that file. So let's go ahead and do that for all three. And here, and then we're going to create a kubeproxy config YAML file. So it's going to be the YAML file, and then create a kubeproxy.service systemd unit file. Same thing here, here, here. Man, I must have a lot of files here. Oh yeah, they're in different directories. So we're going to go ahead and start the worker services. So start container D, kubelet, and kubeproxy. Let's go ahead and do that. Awesome. Works fine. Perfect. Remember to run the above commands. We already did that. So we're going to do verification, list to registered Kubernetes nodes. Okay, we're going to run this from outside, not from internal. So let's go ahead and just do a new terminal. And then let's do this. Oh, yes, it works. So ready, 25 seconds, 23. Oh, this is awesome. Perfect. We should be able to use kubectl. Let me see. Kubectl get nodes. Kubectl get nodes. Okay, that's fine. But great, everything's working fine. So next, we're gonna configure kubectl for remote access. So let's see, how far are we in? Let's see, docs. All right, we're in 10. Okay, we just have a little bit more to go. Let's do it. All right, configuring kubectl for remote access. In this lab, you generate a kubeconfig file for the kubectl command line utility based on the admin user credential. Run the commands in the same lab, in this lab from the same directory used to generate the admin client certificates. So the admin Kubernetes configuration file. If each kubeconfig requires a Kubernetes API server to connect to. To support high availability, the IP address assigned to the external load balancer fronting the Kubernetes API server will be used to generate a kubeconfig file suitable for authenticating as the admin user. So it's going to grab the public IP address, set cluster to this, grab the certificate authority files, use our public IP address to specify the server, set the credentials for admin, and then set context, and then use context. All right, let's go ahead and do that from this directory. All right, awesome. Looks like it worked. So let's run kubectl get version. Kubectl get version. Ooh, I'm missing. Oops. Yeah, there was no get. I don't know where I found get. All right, looks like it works. Client version, server version. Awesome. Then we can list. Oh, yeah, there we go. So that was, yeah, so it didn't work the first time because we didn't have the the file set for the admin user. So now we can just run kubectl get nodes. Kubectl get nodes. Awesome. Let's see. What about pods? Do we have pods? No pods. All right. That makes sense. That makes sense. That makes sense. No problems. Okay, now we're going to provision the pod network routes. All right, let's go ahead and do that. So pods scheduled to a node receive an IP address from the node's pod CIDR range. At this point, pods cannot communicate with other pods running on different nodes due to missing network routes. In this lab, we created a route for each worker node that maps the node's pod CIDR range to the node's internal IP address. There are other ways to implement the Kubernetes networking model. Okay, but we're going to be using this one. In this section, we gather information required to create routes in the Kubernetes hardware VPC network, print the internal IP address and pod CIDR range for each worker instance. Let's go ahead and do that. So we're not doing this from the worker nodes or from the we're not doing this from the worker nodes or from the controller nodes. We're doing this from outside. Oh, actually, we meant to run this command instead. Okay. All right, so we have that. So create network routes for each worker instance. So for each instance, create so for each instance in this network, so the next hop address is going to be this for instance for 21, 22.0. All right. Next hop address and destination range. Okay. So basically defining network routes for each instance based off of like a different IP address or IP address range or destination ranges. So this is the first route created. Second route created. And the final route created. All right, so we can go ahead and list the routes. Let's go ahead and do gcloud compute routes list, tag filter, network, Kubernetes, the hard way. All right, that looks good. So default route, the Kubernetes route 10, 200.0.24. Destination range is this. And the next hop is .20 for this. It's .21, this for 22. All right. And then deploying the DNS cluster add-on. So in this lab, you would deploy the DNS add-on, which will provide DNS-based service discovery backed by core DNS to applications running inside the Kubernetes cluster. So deploy the core DNS cluster add-on. So let's go ahead and do that using kubectl, apply this, and then, all right, we have that output. Then list the pods created by the kube DNS deployment. Oh yeah, there we go. So before we couldn't list any pods because like there was nothing in the namespace. So let's go ahead and do kubectl get pods. Okay, still nothing. But you have to specify. Okay, that makes sense. But yeah, we have the results we're seeking here. And then so we have core DNS VPN and then core DNS PQHH6, whatever that is. So verification, create a BusyBox deployment. Okay, let's go ahead and do that. Created. So let's run that again. Okay, so we see a pod for BusyBox. And then retrieve the full name of the BusyBox pod. Okay, let's do that. All right, so we'll actually store that in a environmental variable, and we can actually look at what is inside that. So echo pod, echo variable pod name BusyBox. Okay, that's it. Yeah, that makes sense. Then execute a DNS lookup for the Kubernetes service inside the BusyBox pod. So okay, so we have server 10.32.010 and the address, and then Kubernetes and this address. All right. Next, we're gonna do a smoke test. Should be fun. In this lab, you will complete a series of tests to ensure your Kubernetes cluster is functioning correctly. So data encryption. In this section, you will verify the ability to encrypt secret data at rest. So let's create a generic secret. So we're going to create a generic secret. Print a hex dump of the Kubernetes hardware secret stored in etcd. So command sudo etcd get endpoints this. So let's go ahead and do that. Oops, not here. Here, actually. And this is the output we should get. So the etcd should be prefixed with K8's AES CBC v1 key on which indicates the AES CBC provider was used to encrypt the data with the key 1 encryption key. Deployments. In this section, you will verify the ability to create and manage deployments. So let's create a deployment for the Nginx web server. So kubectl create deployment Nginx image Nginx. Or just kind of like Docker commands, like when you specify an image for like a Docker container. So next, list the pod created by the Nginx deployment. Let's go ahead and do that. All right, there we go. Let's see. Let's actually see how many pods we have now beyond just Nginx. So we have BusyBox and Nginx. All right, we got that result here. And then port forwarding. In this section, you will verify the ability to access applications remotely using port forwarding. Retrieve the full name of the Nginx pod. So we're just going to put that in an environmental variable. Actually, replace it from what we had before. Forward port 8080 on your local machine to port 80 of the Nginx pod. So let's go ahead and do that. Forward in from local machine to port 80. In a new terminal, make an HTTP request using the forwarding address. Let's go ahead and make a new terminal. Let's go ahead and do Control N. So we have a new terminal here. Wow, so many terminals. So let's curl head. So we should get an HTTP 200 message. Oh, we didn't get that. What happened? Kubernetes kubectl port forward. Let's log in. Oh, come on. Gcloud auth login. All right, let's run that command again. Oh, specify that. Allow. Okay. Let's run that command again. So this one? Yeah. Curl. Yeah, the curl command. There we go. We get a 200 message from our Nginx server that was deployed in that pod. So port forwarding works, which is great. Switch back to the previous terminal and stop port forwarding to the Nginx pod. So let's do a Control C. Oops. Control C. Perfect. In this section, you would verify the ability to retrieve container logs. So print the Nginx pod logs. So kubectl logs. All right, so we have access to logs, and we can see Docker entry point, bunch of logs, started worker processes, Kubernetes logs could be really noisy. But we got that. In this section, you will verify the ability to execute commands in a container. Print the nginx version by executing nginx v command in the nginx container. So let's go ahead and do that. So Kubernetes exec ti pod name nginx v. So I think this exec means execute this command in this pod, and we're able to get that version back. Services. In this section, you will verify the ability to expose applications using services. Expose the nginx deployment using the node port service. Let's go ahead and do that. So kubectl expose deployment nginx type node port, and we see that it's exposed. We have a note here. The load balancer service type cannot be used because your cluster is not configured with cloud provider integration. Setting up cloud provider integration is out of scope for this tutorial. That's fine. Still going to learn more about Kubernetes, so we'll figure that out later on. All right, next, retrieve the node port assigned to nginx service. So we're going to grab that and put that in an environmental variable. And then we're going to create a firewall rule that allows remote access to the nginx node port. So let's go ahead and do that. So basically, create a firewall rule called allow nginx service, and then allow TCP, whatever node port we had here. And then in this Kubernetes the hardware network, let's actually see what that node port has. Okay, so the port was actually 30424. All right, so we have that firewall rule already. Retrieve the external IP address of a worker instance. Let's go ahead and do that. And then make an HTTP request using the external IP address and the nginx node port. So curl and man, come on. See, I think there's an issue with like the environmental variables having issues. So let's just do echo external IP address. Oops. Okay, echo external IP, and then also echo node port. I don't know why it's failing on me every time. So let's go ahead and just do curl. So node port is going to be 30424. And then the external IP address is going to be 35.196.248.203. Please work. All right, there we go. We got a HTTP 200 OK message. Perfect. All right, that's it. And then we're going to go ahead and clean up. So in this lab, you would delete the compute resources created during this tutorial. So compute instances, delete the controller and worker compute instances. So it's going to delete all 3 instances. Let's go ahead and do that. Delete. Oh, come on. What do we have here? So decloud compute instances. Okay, let me go ahead and try. Let me see what happens if I try to delete individually. Gcloud. Compute. Instances. Delete. Controller 0. Oh, I had a typo. Check on the instances, delete. Controller 0. Okay, there we go. Let's go ahead and control. Okay, so controller 0, controller 1. Okay. All right. Controller 2, worker 0, worker 1, and worker 2. There we go. All right, so yes. Perfect. If something doesn't work, I will always find a way. So this might take a little bit of time to delete. So we're gonna wait for the deletion to complete. Well, while we wait for that to delete, we can go ahead and delete the external load balancer network resources. So let's go ahead and do that. Hopefully this command works without us having to alter anything. All right, perfect. That works. And then we can also create a new terminal to, oh, this is already done. So we can go ahead and delete the firewall rules here. All right, let's go ahead and delete this. Oh, we can already close this, so we're fine. And then the VPC, go ahead and delete the VPC. And then delete the compute address. Let's go ahead and make a new terminal and then delete that. Was not found. Why was it not found? Let's go into our Google Cloud Console to see if that resource still exists. Do I still have the console? Okay. We're looking for the addresses. So let's do address. IP addresses. Internal IP addresses, external IP address v4. Yeah, it looks like everything has been deleted. And I don't think I have anything to worry about. The routes. These are all default routes. So it looks like everything has been deleted. So I don't think I should be worried about that. Yeah. IP addresses. I don't see anything here. So I'm gonna assume everything is working. Everything worked out fine. So looks like we're all set with it, and that's the end of it. This was awesome. I loved it. All right, so that's it for the video. This was definitely a really fun project. I enjoyed this. Definitely is a much longer video than expected, but definitely a good learning process to learn like the different components of Kubernetes, like how everything works, like to secure the TLS certificates, the different worker nodes, the controller nodes, the API servers, how all those different components work. I still have a lot of confusion about several things, but this is definitely a great way to start. And I can build more on these basics and learn more about how Kubernetes works. But now that I've done it the hard way, I can start focusing on more security concepts for Kubernetes. And I'll be doing more videos that will be covering more stuff for Kubernetes security as I learn more about them. But thank you for watching this video, and I'll see you in the next video or in the next Kubernetes video. Bye-bye.